For 13 years, he'd been the go-to expert for laser-based equipment that other repair shops couldn't handle. Understanding photonics, beam characteristics, and laser safety with precision that impressed optical engineers, Oliver seemed like every other skilled technician who'd found purpose in keeping technology working. Until industrial laser accidents threatened mass blindness, and everyone discovered that the scanner repairman had designed the safety protocols they were using. Oliver Benjamin Rothschild was 76 years old, with silver hair that always seemed to catch the light from his magnifying equipment, and pale blue eyes that could detect laser beam irregularities through subtle changes invisible to most people. His steady hands moved with practiced precision despite his age, aligning optical components and calibrating laser systems with tolerances measured in micrometers, while his voice carried the careful cadence of someone who understood that laser technology involved electromagnetic radiation powerful enough to cause instant, permanent blindness if safety procedures were compromised. Welcome to the Human Stories. Before we continue this incredible tale of hidden expertise and sight-saving laser knowledge, tell me in the comments what city you're watching from today. And if you believe stories about quiet masters deserve to be heard, hit that subscribe button. Precision Laser Repair operated from a cluttered workshop in San Jose, California, where Oliver had built a reputation for fixing laser-based equipment that other technicians considered unrepairable. His specialty was barcode scanners, laser printers, and optical measurement devices that required understanding of photonics, beam physics, and safety protocols that exceeded what most electronics repair shops could provide. Oliver had worked as an independent laser technician for 13 years, serving retail stores, warehouses, and small manufacturing facilities that depended on laser-based systems for inventory management, quality control, and automated operations. His repairs went beyond simple component replacement. He performed optical alignment, beam characterization, and safety verification that ensured laser equipment operated within specifications that protected both operators and customers from potentially dangerous radiation exposure. His approach to laser repair combined technical precision with comprehensive safety analysis, helping clients understand how laser systems worked, what safety margins were required, and how to maintain equipment that involved invisible electromagnetic radiation that could cause eye damage faster than human reflexes could respond. Mr. Patterson, your warehouse scanner is showing beam divergence that indicates the laser diode is beginning to fail. While it's still functioning for barcode reading, the increased power output could exceed Class 2 safety limits. I recommend replacement before it becomes a vision hazard for your workers. These safety consultations represented more than routine equipment repair. They were professional laser safety assessments that prevented accidents by identifying developing problems before they reached dangerous levels that could cause permanent vision damage to workers who didn't understand the invisible risks of laser radiation. The electronics repair community in Silicon Valley had come to respect Oliver's expertise and thoroughness. His laser repairs lasted longer than work performed by other shops. His safety assessments prevented accidents that could have resulted in expensive liability claims, and his patient education helped business owners understand laser technology well enough to make informed decisions about equipment purchases and maintenance schedules. What impressed colleagues most was Oliver's ability to troubleshoot laser problems that stumped consulting engineers, diagnosing beam quality issues, optical alignment problems, and safety system failures through analysis that combined theoretical knowledge with practical understanding of how laser systems behaved under real-world operating conditions. What none of them realized was that Dr. Oliver Rothschild had spent 38 years developing laser systems with power levels and complexity that made commercial barcode scanners look like flashlights by comparison. Oliver lived alone in a comfortable house in the hills above San Jose, where he had chosen to retire to a location that provided clear views of the technology companies. The morning proceeded normally until 11:15 a.m., when Oliver received a call that triggered 38 years of laser safety experience. TechFlow Manufacturing, a semiconductor fabrication facility 15 minutes from his shop, was experiencing laser safety incidents that were affecting workers in their precision etching operation. The problems weren't immediately catastrophic, but they represented developing safety failures in industrial laser systems that operated at power levels capable of causing instant, permanent blindness or severe tissue damage. Dr. Rothschild recognized the emergency immediately. Laser safety system failures that could escalate from minor exposure incidents to mass casualty accidents if the underlying safety defects weren't identified and corrected within hours. Mr. Rothschild, this is Safety Manager Jennifer Kim from Tech Flow Manufacturing. We understand you work with laser systems. We're having some safety issues with our industrial laser equipment that our engineers are having trouble resolving. Dr. Oliver Rothschild faced a choice that would define his impact on laser safety. He could operate as a standard electronics repair technician, declining involvement in industrial laser issues, while hoping that manufacturing engineers would resolve safety problems through their own analysis. Or he could use 38 years of expertise in laser systems to prevent photonics disasters the way he'd been trained to do when similar problems emerged during his defense industry career. Oliver made his decision in approximately 8 seconds. Ms. Kim, this is Dr. Oliver Rothschild, Laser Systems Engineer. I'll need to see your laser specifications, safety system documentation, and incident reports to provide useful analysis of the safety failures you're experiencing. Over the next 10 hours, Oliver coordinated laser safety analysis that identified fundamental design flaws in protective systems that could have caused catastrophic accidents affecting dozens of workers. His investigation revealed that TechFlow's industrial laser operation contained safety system bypasses that would allow dangerous beam exposure under specific operational conditions, potentially causing mass blindness during routine manufacturing operations. His electronics repair experience provided practical understanding of how laser safety systems failed in real-world environments, while his defense industry background enabled analysis of high-power laser hazards that exceeded anything commercial safety engineers typically encountered. Dr. Rothschild, our laser safety equipment meets all OSHA requirements and industry standards. How did you identify safety problems that our consulting engineers didn't detect? Asked Oliver, looked around the TechFlow facility where his laser safety expertise was now preventing potential disasters. Ms. Kim, I've spent 38 years designing laser systems and the safety equipment required to use them without injury. The safety system problems you're experiencing create exposure pathways that can cause permanent vision damage or worse during normal operations. But Oliver's investigation revealed something more serious than routine safety equipment problems. The laser safety system bypasses were occurring in patterns that suggested deliberate sabotage rather than accidental equipment modifications, indicating coordinated attacks on industrial safety systems that could cause mass injuries while appearing to be routine maintenance errors. Ms. Kim, the safety system modifications I'm analyzing aren't consistent with normal equipment maintenance or operator error. The bypass installations suggest intentional tampering designed to cause laser exposure accidents while avoiding detection through standard safety audits. Within 24 hours, federal agents specializing in industrial sabotage were working with Oliver to analyze evidence that revealed domestic terrorism targeting laser-equipped manufacturing facilities throughout Silicon Valley. The investigation that followed exposed attempts to compromise laser safety systems serving thousands of workers, designed to cause both immediate injuries and long-term economic damage from facility shutdowns and liability claims. Dr. Rothschild, how did you identify the sabotage patterns when our industrial safety engineers didn't detect deliberate tampering? Asked FBI Special Agent Maria Santos during the investigation coordination. Oliver looked across the manufacturing facility where enhanced laser safety measures were being implemented based on his photonics analysis. Agent Santos, I've spent my career designing laser systems that have to operate safely under all conditions, including potential sabotage attempts. When you understand how laser safety systems are supposed to function, deliberate modifications become obvious through their effects on beam containment and exposure prevention. The investigation that followed exposed a domestic terrorism network that had been systematically compromising laser safety systems as part of a coordinated attack on American manufacturing capabilities. Oliver's analysis had prevented what could have been mass blinding accidents affecting hundreds of workers across multiple facilities. The story remained largely within laser industry publications, protecting both operational security and Oliver's privacy, while ensuring that laser safety protocols received improvements based on vulnerabilities that had been exploited by criminal organizations.
Oliver returned to his laser repair business, fixing equipment with the same methodical precision that had characterized his pre-emergency work. But something had changed in his relationship with the photonics community and his understanding of how his expertise could continue serving laser safety. "Oliver, thank you for identifying the problems with our laser safety systems," said client Rebecca Martinez, whose packaging company used laser marking equipment during a routine service call.
The news mentioned some issues with industrial lasers that got resolved quickly. Oliver looked around the facility where he was calibrating a laser marking system that would operate safely for years through proper maintenance and safety oversight. "Rebecca, I've been working with laser systems for most of my adult life, whether it's repairing barcode scanners or protecting people from high-power lasers. The physics stays the same. Laser radiation requires constant respect and proper safety measures. Were you involved in fixing the laser safety problems?" Oliver smiled, adjusting his repair shop badge that covered federal credentials he'd hoped never to need again. "I've spent my career making sure laser systems work safely and reliably. Now I get to apply that knowledge to keeping everyday laser equipment functioning properly, rather than designing military laser systems." Dr. Rothschild continued his laser repair business until he was 83, serving as informal laser safety consultant for OSHA while maintaining the trusted repair service that kept small businesses operating efficiently and safely. Because he learned that the most effective laser safety often comes from people whose expertise exceeds their visible roles, whose dedication continues regardless of official titles, and whose photonics knowledge serves both individual businesses and industrial safety with equal commitment to ensuring that laser technology enhances rather than endangers the lives of the people who work with systems that harness the power of light. The enhanced laser safety protocols that resulted from Oliver's intervention became standard throughout Silicon Valley manufacturing, demonstrating how expertise developed for high-power military applications could be essential for protecting workers who use commercial laser systems that seemed safe but could cause devastating injuries if safety systems failed. Oliver's contribution to laser safety extended beyond preventing immediate sabotage to establishing monitoring systems that would enable early detection of future threats while maintaining the technological innovation that made Silicon Valley a global center for advanced manufacturing and electronics development.